Hello everyone, today we are going to start section 261 notes, but before we do that we're going to do a warm-up here, whether that's with yourself, a partner, in a group, a little bit of matching, A, B, C, D, E, what goes in these three blanks. So push pause, go through that, and try to put those in the order you think is appropriate. Okay, this is an example of what we would call a proof and what we call a flowchart proof. There's actually going to be three different types of proofs that we do: flowchart, two-column, and paragraph. Okay, I moved the diagram down just a little bit. Okay, we were actually given in the proof, and I moved it down a little bit, the first step, measure of angle 1 is equal to the measure of angle 3. So in other words, they're congruent, which is already marked on the diagram. Then the reflexive property shows us that angle 2 is congruent to itself. Okay? And then the last step is, if we add these two together, 1 and 2 together, and 2 and 3, hopefully this makes sense. It's what the book calls angle addition postulate or property. We're going to write that a little bit differently. But if you add, so we know angle 1 and angle 3, so if I just put numbers to this, so let's just say that these are 10 degrees and 10 degrees. So let's say angle 2 is 5 degrees. So if I combine these two angles, they'd have to be 15. But if I also combine these two, they would also have to be 15 because they're adding congruent angles to the same angle. That is how we're actually going to word it. So that's the angle addition postulate. Okay, and there's a way to write this as a two-column chart as well, and your two-column chart would look more like this. So you would have your statement over here, and then your reasons over here. Sometimes I put just S and R. So again, this over here would be measure of angle 1 equal to measure of angle 3, which is given, 2. Measure of angle 2 equals, I forgot the angle symbol in there, so I'll squeeze that in there, of angle 2. That is reflexive property. And then last but not least, the proof statement, angle EBA is equal to the measure of angle CBD, and we would write add same angle implies congruent angles. Okay? So that is a two-column versus a flow chart. So again, this is a two-column chart here, or in other words, two-column proof. Those would probably be our main formats, but we will also use paragraph proofs as well. Okay, so let's talk about a couple congruent supplements and congruent complements theorems that we have here. If angle 1 is complementary to angle 2 and angle 3 is complementary to angle 2, well, these are the same angle, right? So if they're complementary to the same angle, no matter what this measure is, these two have to be congruent, okay? So angle 1 would have to be congruent to angle 3. Because if this is 40 degrees, they both would have to be 50. The other one is if you have, here's kind of our link. These two angles are congruent. So if these two angles are 40 degrees, these are both 40 degrees, so these would both have to be 50 degrees. So angle 1 is congruent to angle 4. And it doesn't matter if these are supplementary or complementary. So again, if it's to the same angle, so this is same angle here, 1 and 3 would be congruent. And again, here's our link. If they're to the supplementary to congruent angles, again, they still would have to be congruent. So it doesn't matter if these, it can't be complementary, supplementary, so they either both need to be supplementary or both be complementary. But again, that's kind of the link that you're looking for here. Okay, so as you see when we go through all these problems, we really have algebraic problems that we do, and then we're also going to have proofs that we do. So let's take a look here first at an algebraic example. So here we have angle PQR is supplementary to angle QRS. But we also know QRS, here's our link, is supplementary to angle TWZ. So we know this angle and this angle must be congruent. Okay, so we can set them equal to each other. 5x minus 48 equals 2x plus 30. And if we go ahead and solve that, we get 3x equals 78, and x is 26. Okay, so again, as I always say, plug it back in, right? Read the question. Is this what we're looking for? We're looking for angle QRS. Well, if we plug 26 back into one of these, so I get, I'll just do it here. 2 times 26 plus 30, so that's going to give us what, 52 plus 30, so we get that to be 82. But we know QRS is supplementary to that, so they got to add up to 180, so that's going to give you 98 degrees there for angle QRS. Okay, so now let's write a couple proofs. And again, flowchart we're going to start off with, just like our warm-up there. So we have that our given statement, WXZ is congruent to angle VXY. That is given. And we kind of just write that in parentheses below. So this is our statement, and this is kind of the reason why it is. Okay, so WXZ, so I'm going to kind of do a little squiggly here, and VXY, they are congruent. Well, hopefully you saw as I drew these blue squiggly lines that they overlapped right in this middle here. Whenever you see that, you should be thinking same angle. So what do I mean by that? Angle 2 is congruent to itself. That is by the reflexive property. So now we can think about subtracting that angle off. So if we subtract it off from the larger angles, we know angle 1 is congruent to angle 3, which is what we happen to be proving here. So this is by the subtraction property, okay? But if you subtract the same angle, then it implies congruent angles. Okay, so we are definitely in a flowchart, and even in our 2 column, we are shortcutting this just a little bit with our implies there. So let's take a look at another one. This one we're going to do as a 2 column. So our statements, angle 1 congruent to angle 4. Again, I'm always marking that on our diagram here. That is given. And we have no other givens, so let's just take a look at our diagrams here. Well, I've got a couple things going on here that I can assume from diagrams, right? Especially if we run out of givens. Go to your assumptions. What can you assume? Straight angles, therefore we have something that's supplementary. Straight angles, supplementary. So yes, we definitely have those as supplementary, so we can say a couple different things here. Let's start with this one here. Angle 1 and angle 2 are a linear pair, and that's by the diagram. We can also say the same thing about 3 and 4. I'm going to use my little ditto quotes there, and again, that's by my diagram. So how does this help us? Well, now we can say that angle 1 and angle 2 are supplementary. So a linear pair implies supplementary because they're adjacent. And we can say the exact same thing about angles 3 and angle 4. Again, if you want to rewrite it, or you can use, again, these little dittos, that's absolutely fine to do that. All right, so let's see. Do we have a link? And we absolutely do. So I like to kind of highlight that. We have 1 and 4, so this angle and this angle are a link. They are the same measure. So we know, absolutely know that 2 and 3 are congruent to each other. So supplementary, I'm going to put 2 congruent angles implies congruent angles. And we look back up here, and that is, I switched the order, but same thing. That is what we have. Okay. Okay, I would actually like you to try this one on your own. We're going to do this one as a flow chart. Please write this down and push play when you're ready to check your answers. And then we'll go through it once you've done that. Okay, so we have perpendicular. So we know that we have a right angle, which is what we're stating here. Perpendicular implies right angle. Therefore, 2 and 3 must be complementary. We also know that 1 and 2 added together equal 90, which also means that angle 1 and angle 2 are complementary. No way to mark that on our diagram. We just kind of got to know that. And again, what's the link here? I can highlight that for you. So same angle right here. 2 angles are complementary to the same angle, then they are congruent. Okay? So that is that proof. Let's take a look at the next one. Right as a flow chart. Okay, so 1, we have NE, rate NE bisects angle RNK, and that is given. So that tells us, so if there's something I can mark from the diagram, there's another step I need to put there. So ray NE bisects angle RNK, so angle 1 is going to be congruent to angle 2, and that's really because of what bisect means. So bisect implies 2 congruent angles. Okay. So again, we ran out of givens. What can we go to? Our assumptions, right? Straight angles, which means supplementary. We can also get some vertical angles in there. So let's see here. We are trying to prove that 3 is congruent to 4. So we're trying to match up these 2 angles. Well, the best way I can kind of see that, since I'm looking at these 2 angles here, I know 1 and 4 are vertical, and 2 and 3 are vertical. Okay, so let's take a look at that. So let's see here. So we know that angle 1 is congruent to angle 4. So vertical angles imply congruent angles. Okay? So we know this. And notice I'm writing right over that blue line to get that congruent to 4. And then here we can also do angle 2 is congruent to angle 3. And it's really the same as 4, and you're welcome to write that. It's just a short, I feel, just to write this. Congruent angles implies, vertical angles imply congruent angles. So we have a bunch of congruent statements. So this is kind of thinking about the chain rule type thing, but it's really the transitive property. So angle 3 is congruent to angle 4. So angle 3 is congruent to angle 2, but angle 2 is congruent to angle 1. And angle 1 is congruent to angle 4. So in the end result, 3 is congruent to 4, and that's by the transitive property. And again, because we are using a flowchart, our arrows tell us the links there. Okay, so that was a little review from previous. Okay. All right, and now, last but not least, let's talk about this, and then I'm going to let you guys finish this up for class. Okay, so we have angle 2. Same diagram really is congruent to angle 4. 2 is negative 4x plus 5y. Notice that's the first thing I'm doing. I'm marking up my diagram. Mark it, put your work on your diagram so you can pull your equation off of it. Angle 3 is 2x plus 5y. Angle 1 is 20 degrees. Find x and y. Okay, so think about what we did in our previous example. Maybe that might help you a little bit. But again, we are looking for X and Y here. And then come into class the next day with your answer and we can review that. So this concludes our notes from the first day of 2-6.